Hey, it's Mr. Estrada here, and our learning target is to be able to say at the end of this video, I can identify chords and find their lengths using the intersecting chords theorem. So let's get right to it. What is a chord? A chord is a segment that joins 2 points of a circle. So we have a circle here, and I'm going to go ahead and draw a couple of chords for you. So a chord just joins 2 points of a circle. So here is a chord. It's joining 2 points of the circle. And let's go ahead and call this point A, call this point B. So AB is a chord. Let's go ahead and draw another one. Here's another chord. It joins 2 points of a circle, and let's go ahead and call this chord CD. So there you go. A chord is just a segment that joins 2 points of a circle. Now, the intersecting chords theorem says the following. If two chords intersect in a circle, the product of the lengths of the segments of one chord equal the product of the segments of the other. So take a look at this diagram right over here. This theorem is basically saying A times B equals C times D. Or another way to say it is segment piece times segment piece equals segment piece times segment piece. A and B must be on the same chord. C and D must be on the same chord. That's why it says segment piece times segment piece, right? A and B are pieces of the same segment. So that's what the intersecting chords theorem says. Simply put, A times B equals C times D. So let's work out an example using this theorem, but first let me give you some steps I'm going to follow. And here's our first example. So it says in the accompanying diagram, A, B, and C, D are chords of the circle and intersect at E. If AE equals 10, EB equals 9, and CE equals 6, find DE. So if we go back to our steps, the first step is to label the diagram with the given measurements, which is already done for us. Our second step is to label the unknown segment X. So I'm going to go ahead and label DE X. So this segment is going to get labeled X. The next part says, if necessary, partition the segments. This is not necessary for example 1, but it will be for example 2. So we'll talk more about this when we get to example 2. Step 4 says, write the formula. So the formula says A times B equals C times D. Now here, it might be helpful to go ahead and label A and B and C and D. Now remember, A and B must be on the same chord. So for me, I'll make this A and I'll make this B. And they are on the same chord, right? They're on the same chord, A, B, so that's okay. And I'm going to go ahead and label 6 and X, C, and D. And they are on the same chord. That's the important part, okay? A and B must be on the same chord, and C and D must be on the same chord. So we substitute, we simplify that, and we're going to simplify it even further by dividing both sides by 6. This cancels out, and we get 15 equals X. So we could say segment DE equals 15. That's our final answer. Let's try another example. In the accompanying diagram of circle O, chords AB and CD intersect at E. If AE equals 2, CD equals 9, and CE equals 4, find BE. So let's go ahead and label our diagram first. AE is 2. CD is 9. Now this is very, very important. When it says CD, it's talking about the whole chord, not a piece of it. It's talking about the whole chord. It's saying the whole chord, CD, this whole thing here is equal to 9. That's a very important distinction. Then it says CE is equal to 4. So Let's make that 4. And it says find BE. So let's go ahead and label BE X. So BE is X. Okay, now here is the part where we have the partition. In order for us to use our formula, we need an A and a B and a C and a D. And so far, what we have is an A. We don't have a B. We do have a C, and we do have a D, but we don't have a B. So how do we get that B? This is an A, by the way. That's supposed to be an A. So we don't have a B. So how do we get it? We have to partition. That means cut into parts the segment. So we have to cut into parts the chord CD. So we know the whole thing is 9. We know this part is 4. So what must the other piece be? Well, it has to be 5, because 5 plus 4 gives you 9. So now with that, we plug into our formula. So A, this is my A, this is my B, this is my C, and this is my D. So I get 4 times 5 equals 2 times X. Simplify that. 20 equals 2X. Simplify it even further. You get 10 equals X, which means segment BE equals 10. That is our answer. All right, before I get to example 3, I got to go over another theorem real quick. And I'm going to call this the diameter perpendicular to chord theorem. And it essentially says if the diameter is perpendicular to the chord, then it bisects the chord. So let me show you what that looks like. So say you have a diameter, which is a chord also, by the way. A diameter is also a chord because it joins 2 points of a circle, right? So say you have a diameter that is perpendicular to the chord. So I have to draw this other chord in such a way that it's perpendicular to this diameter. So you can see there, right? These are perpendicular. So if you have a diameter that's perpendicular to this chord, what it does is the diameter bisects the chord. And all that really means is that, let's call this point A, we're going to call this point M, and we're going to call this point B. What this theorem is telling you is that that diameter is cutting AB into 2 equal parts. So we could say AM is equal to MB. That's what this theorem is telling you. Now let's go ahead and use it. It says in circle O, diameter AB is perpendicular to chord CD at E. If AE equals 16, so we know that this segment piece here is 16. And we know EB is 4. So this is 4. EB is 4. What is CD? So I labeled, and I got to label my X. Now, I could label the whole thing CDX. But what I'm actually going to do a little audible here. And what I'm going to do is I'm going to label CEX. Now, remember what we just looked at, this theorem here, right? It says that if a diameter is perpendicular to a chord, then it bisects the chord. AM is equal to MB. So if CE is X, that means ED is also X. Once I find out what X is, then I can just add them up to get CD. So I'm going to write my formula down. A times B equals C times D. I'm going to make this my A. I'm going to make this my B. This will be my C. And then this will be my D. So doing that, I get X times X equals 16 times 4. That works out to X squared equals 64. The only way you could get rid of this square here is by square rooting both sides. So both sides are square rooted. X equals 8. That's not my final answer, right? CD is the whole chord. X is only half the chord. So if I want to get the length of CD, I have to add 8 plus 8, and that's going to give me 16. So the final answer is CD equals 16. Okay, so that's it for this video. We went over what a chord is and the intersecting chords theorem and how to apply it. Hope this helps. Have a great one.